Hello, bedtime thinkers, and welcome to the Bedtime Discoveries. I'm so glad you're here tonight. This is your quiet little corner of the universe, a place where you can drift away while we explore the wonders of science. Together, tonight, we'll take a slow and gentle journey into the lives of stars. We'll learn how they are born, how they shine, and how they eventually say goodbye. It's a story as old as time itself, a story written in the night sky above us. And I'll share it with you in the calmest way possible so you can relax and rest. Before we begin, I'd love to know where in the world you are watching from and what time it is for you right now. Are you settling down late at night? Or perhaps listening in the soft hours of the morning? Let me know in the comments. I always enjoy reading where these bedtime discoveries are reaching. And if you find comfort here, please gently tap the like button and consider subscribing to this channel so you can join me again for more calm journeys through science and wonder. Close your eyes and imagine yourself drifting in the quiet stillness of space. There's no sound here, no rush, no hurry, just endless darkness, stretching out in every direction. But within that darkness, there are hidden places, clouds so vast, so gentle, and so ancient that they hold the seeds of future suns. These are nebulae, the birthplaces of stars. To the eye, they can look like faint smudges when seen through a telescope, or like delicate clouds of color in long-exposure photographs. But to the universe, they are nurseries where gravity begins its patient work, and where the first chapters of a star story quietly unfold. Nebulae are made of gas, mostly hydrogen, the simplest and most abundant element in the universe, and dust, tiny grains left behind from older stars that once lived and died. These particles drift together like whispers in the night, gathering slowly, invisibly, across distances so vast that even light, traveling at unimaginable speed, would take years, centuries, or even millennia to cross them. If you've ever seen the famous Orion Nebula, you've already gazed into such a cradle of creation. It lies just below Orion's belt, glowing faintly in the night sky, and within it, young stars are being born even now, hidden within swirling clouds of gas. Think of a nebula as a nursery, where baby stars are tucked in, waiting for their moment to shine. But unlike human children, their birth takes millions of years. Time so slow and so calm that it is difficult for us, bound by short lifetimes, to truly imagine. Nebulae come in many forms. Some are bright emission nebulae, glowing with light from nearby stars. Others are dark nebulae, cold clouds that block the starlight behind them. And some are reflection nebulae, softly shining with the light of other stars. But all of them share a common purpose. They are the starting point, the gentle womb of the cosmos, where the journey of every star truly begins. Imagine drifting inside one. The light around you would be dim, colors muted, blues and purples, reds and faint greens, like watercolors spreading softly across the night. Tiny motes of dust would float by you, but there would be no breeze, no sound, only the infinite stillness of space. And yet, in that silence, something is happening. Tiny clumps of matter begin to gather, like raindrops forming in a cloud on Earth. Each clump grows a little heavier, it pulls a little stronger, and slowly, the process of star birth takes its first invisible steps. We often think of stars as eternal, always shining, always present, but in truth, Every star you see in the night sky was once hidden inside a nebula, waiting for gravity to gather its pieces and for its heart to ignite with fire. When you look up tonight at the Milky Way, that soft band of light across the sky, remember that much of that glow is dust and gas, a galaxy filled with countless star nurseries, each one holding the future suns of tomorrow. The story of stars begins not with fire, but with silence, with drifting particles, with patience, and with clouds so vast that they stretch across hundreds of light years. It is in this stillness that the universe prepares its greatest wonders. Imagine yourself floating deeper into the heart of a nebula. The stars in the background grow faint. As the thick clouds of gas and dust surround you, it feels almost like being inside a dream where colors swirl slowly, shadows curl and twist, and everything moves in silence. At first glance, it may look calm and unchanging, but hidden within the stillness, an invisible force is at work. That force is gravity. Gravity is like the gentle hand of the universe, always pulling, always gathering, never rushing, never stopping. Even in these clouds of gas and dust, where atoms float far apart, gravity begins to tug at them, drawing them closer, grain by grain, molecule by molecule. Over time, these drifting atoms start to collect into small clumps, and though they are tiny at first, they grow heavier, and their pull becomes stronger. It is as if the nebula itself is quietly knitting together patches of gas into seeds of new stars. On Earth, we can see something a little similar in clouds in the sky. When water vapor gathers, the air slowly forms drops, and eventually a cloud becomes heavy with rain. In the same way, the nebula grows heavy with clumps of hydrogen gas. But while an Earth cloud may form rain in a matter of hours, a star's cloud takes millions of years, and the rain that eventually falls is not water but light. Astronomers call these growing clumps protostars. They are not yet true stars. They do not shine brightly. Not yet, but they're slowly forming. Gathering material, like a child drawing breath before first cry. If you could drift closer, you might notice that the inside of a protostar is warming. The gas grows denser. The atoms bump into each other more often, and slowly, the temperature begins to climb. Imagine being inside a cocoon, where warmth spreads softly, unseen. That's what a forming star is like, a hidden ember, tucked away in the clouds of the nebula, growing hotter, until one day it will finally ignite. But this process is incredibly slow, so slow that if you could watch it, you would see nothing change in your lifetime, or even in thousands of lifetimes. Yet the universe waits patiently for gravity to do its work. Some nebulae are especially famous for their star nurseries. The Eagle Nebula, with its towering pillars of creation, looks like great stone columns, but they are made of gas and dust, and inside them, new stars are forming right now. There's the Carina Nebula, so large that if you placed our sun inside it, it would take light years just to travel across. And then the quiet, dark nebulae that look like patches of emptiness in the sky, but are in fact thick blankets of dust, hiding whole clusters of baby stars. Within, the universe is full of these nurseries, each one like a cradle, rocking gently in the vastness of space. It's humbling to think that the very atoms inside your body once drifted through a nebula long before Earth existed. Long before the sun lit its first fire, the hydrogen in your cells, the carbon in your bones, was dust floating in the darkness. And just as those clouds gather to form the stars we see now, so too will the dust from dying stars one day form new generations of suns, new planets, and perhaps new life. The nebulae are not just the birthplace of stars. They are the birthplace of everything. So the first step in the life of a star is not fiery or dramatic. It begins with silence, with gas and dust, with gravity's patient embrace, and with time, so much time that we can only marvel at its scale. The stars we see above us are proof that even in the quietest places, the universe is always creating. As we drift deeper into the heart of the nebula, let us pause for a moment and think about just how vast these clouds truly are. A single nebula can stretch across hundreds of light years. To cross from one side to the other, even if you were riding on a beam of light, would take centuries. And yet, inside this immensity, stars are forming silently, in countless numbers. Some of these stars will be small and faint, burning softly for billions of years. Others will be enormous giants, blazing brightly, but burning out quickly, each one unique. Each one destined to follow its own path. But for all of them, the story begins here, inside these quiet clouds of gas and dust. If we could stand still and speed up time by millions of years, we would see the nebula change before our eyes. At first, faint ripples of gravity would pull matter into small knots. Those knots would grow larger, glowing faintly as they heated, and then whole clusters of stars would flicker to life, like candles being lit in the dark. Some nebulae already reveal this magic. When we point our telescopes at them, we see whole regions filled with newborn stars, their light scattering the gas around them, creating colors and shapes, like cosmic paintings on the canvas of the night. The Orion Nebula, for instance, holds thousands of young stars, many only a few million years old, a blink of an eye in cosmic terms. And in those stars, planets are beginning to form, small disks of dust and gas spinning around them, waiting to become new worlds. It's a gentle reminder that the sky above us is alive with creation. Every twinkle we see at night has a story that began in one of these nebulae. And perhaps, even now, in some hidden corner of space, a star is being born at this very moment, its light not yet reaching us, but destined to shine upon the universe one day. This thought carries with a quiet comfort we are part of something vast, something ongoing, something eternal. Even as some stars die, new ones are always being born. The universe never stops. Its rhythm is slow, patient, but unending. Let us imagine now, floating gently out of the nebula, looking back, we see its glowing shape spread across the darkness, a cradle of creation, stretching farther than we can see. Inside it, hidden from view, protostars are still forming, tiny embers waiting to awaken, waiting for the spark of nuclear fire. The birthplace of stars is both quiet and alive. It is a reminder that creation does not need noise or speed. Sometimes the most powerful beginnings are also the gentlest. And so, the first chapter of a star's life ends here, in the womb of the cosmos, where dust and gas come together, and prepare for the moment when a star's heart will ignite. Drift with me now, as we leave behind the vast nebula, the cradle of stars, and turn our attention to the force that shapes everything within it. This force is gravity. Gentle, patient, unyielding, gravity is the quiet architect of the cosmos. It binds galaxies together. It shapes planets. It keeps our feet on the earth. And in the stillness of a nebula, it is gravity that begins the birth of a star. Imagine for a moment that you are a single atom of hydrogen floating inside a nebula. For countless years, you drift silently, surrounded by other atoms, but never touching them, never bound to them. And then, slowly, you begin to feel the faintest tug, an invisible hand pulling you closer, not just to one atom, but to all of them. That hand is gravity. It does not rush, it does not force, but it never lets go. And over millions of years, that steady pull draws the gas and dust together, forming a clump that will one day become a star. We often think of gravity as something ordinary because we live with it every day. It holds us to the earth. It pulls a ball down when we drop it. It shapes the tides in the oceans, caused by the moon's gentle tug. But gravity is far from ordinary. It is, in many ways, the sculptor of the universe. Without it, stars could not exist, planets could not form, and galaxies would simply drift apart into nothingness. The pull of gravity is everywhere, yet we cannot see it. We only see its work in the way objects move, in the way light bends, in the way clouds of gas come together to ignite new suns. Now picture again the heart of a nebula. Inside, tiny clumps of matter are forming. Each one is pulled together by gravity, and as it grows, its pull becomes stronger. It gathers more and more material, like a snowball rolling down a hill, slowly gaining size and weight. This process is not quick. It unfolds over millions of years, so slowly that from our human perspective, the cloud seems still, unchanging. Yet, if we could look across eons, we would see the nebula slowly collapsing, its gas swirling into spirals, its dust gathering into knots, each knot the seed of a new star. Think of a child building a sandcastle on the beach. They scoop handfuls of sand, press them together, and shape them into towers. Gravity is doing something similar, but on a cosmic scale. Instead of sand, it gathers atoms. Instead of towers, it builds suns. And though we cannot see gravity, we can feel its quiet persistence. Here on Earth, we feel it every moment. It holds the oceans in their place. It keeps the air wrapped around the planet. It cradles us gently, though firmly, reminding us that we belong here. So the journey of every star is really the journey of gravity. From scattered dust to glowing suns, gravity guides every step, with patience and with time. And as we drift here together, thinking of the stars above us, we too can feel that pull, not just the physical pull of gravity, but the quiet reminder that even in the vastness of space, there's always something drawing us together. Let us return to the quiet interior of a nebula where gravity is at work in its slow, steady way. At first, the gas and dust float loosely, like smoke drifting in the air, so light, so fragile, that it seems as though a breath could scatter it. But gravity has no need for haste. It waits, it tugs, it gathers. Each tiny atom feels the pull, and as they drift closer, their combined weight grows heavier, and the attraction stronger. What begins as a thin cloud slowly collapses into knots and clumps, regions astronomers call dense cores. Within these cores, the pressure begins to rise, and with it, the heat. If you could step into one of these forming cores, you would see nothing like a star. Not yet. You would find swirling gas, particles colliding, temperatures climbing as the cloud tightens inward. At the very center, a faint glow would begin to emerge, not the bright light of a burning sun, but a soft, hidden warmth. Astronomers call this stage the protostar. It is like the beating heart of an infant, soft, faint, and new. The protostar has not yet awakened fully, but the signs of life are stirring inside it. To understand this, imagine cradling a piece of coal in your hands. At first, it is cold and dark, but if you press it hard enough, if the weight upon it is great, it changes. Its atoms shift, its structure bends, until the pressure makes something new. This is what gravity is doing inside the protostar. The weight of the gas above presses down, and the atoms inside are squeezed together. The pressure creates heat, and the temperature begins to climb, millions of degrees, hotter than anything on Earth. And yet, even now, the star has not truly begun. It is like a child just before its first breath, alive but waiting on the edge of awakening. Here on Earth, we can see hints of gravity's patience in other ways. The flow of rivers, carving valleys over centuries, mountains rising slowly from the earth, planets orbiting the sun, never straying too far. Gravity works in silence, yet it leaves marks everywhere. It holds galaxies in graceful spirals. It bends a path of starlight as it travels, and in these hidden clouds of gas, it patiently shapes the raw material into something that will shine for billions of years. The beauty of gravity is that it does not create in haste. It is a sculptor who works with infinite patience, chipping away, smoothing, shaping, until the formless cloud has become a star. If you could watch a time lapse of a nebula over millions of years, you would see the clouds collapse, you would see knots brighten, and stars flicker into being, like lanterns, slowly lit one by one across the canvas of the sky. It's humbling to think that our own sun was once such a protostar, 5 billion years ago. In a quiet corner of the Milky Way, gravity gathered a cloud of hydrogen, pressed it into a dense core, and slowly warmed it into life. All the light, all the warmth, all the life we know can be traced back to that gentle pull of gravity. So as you imagine yourself drifting through the nebula tonight, picture those hidden cores, those unseen embers, forming quietly under the hand of gravity. They are not yet stars, but soon they will be, and when they awaken, they will shine across the universe for billions of years to come. As the protostar grows warmer, gravity continues its quiet work. It presses the gas inward, tighter and tighter, until the very core glows with heat. But the story of gravity does not end with the birth of the star. In truth, gravity will guide that star for the rest of its life. Picture the newborn star. It begins to shine softly, its light reaching out into the darkness. Around it, the leftover gas and dust swirl into a disk, spinning gently like flowers stirred in water. This disk is where planets are born. Tiny grains of dust collide, stick together, and slowly grow into pebbles, rocks, and eventually worlds. Every planet, every moon, every asteroid is sculpted from this disk, and every step of their journey is guided by gravity's pull. Our Earth, too, was once part of such a disk. Billions of years ago, dust and stone gathered, pulled together by gravity, until our world took shape. The oceans, the mountains, the sky above us all owe their existence to that ancient pull. And so, gravity is not only the creator of stars, it is the creator of homes, of planets where life might one day emerge, just as it did here. But gravity's reach extends even farther. It is the reason stars gather in families, clusters, spinning together in galaxies. It is the reason galaxies themselves drift and collide, merging over billions of years in a slow cosmic dance. Imagine two galaxies drawn together like partners across a ballroom floor. They spin, they twirl, their stars weaving among each other, yet rarely colliding, all guided by gravity's patient rhythm. This dance has been repeated countless times across the history of the cosmos. And one day, our Milky Way will meet the Andromeda Galaxy 1 billion years from now to join in that same slow embrace. Gravity, the same gentle force that pulls an apple to the ground, is also the force that guides entire galaxies and gives shape to the universe itself. It is both intimate and infinite. It holds you in your bed tonight, and it holds the stars in their courses across the heavens. But gravity's story has a quiet balance. In a star, gravity pulls inward while the fire of fusion pushes outward. These two forces remain in harmony, allowing the star to shine steadily for billions of years. Without gravity, the star would never have formed. Without the pressure it creates, fusion would never have begun. And so, gravity is not only the beginning, it is the guardian, the silent companion that walks beside every star from birth to death. Think for a moment about how remarkable this is. The same law of nature that keeps the moon circling the earth is the law that creates suns and shapes the destiny of galaxies. The same quiet pull you feel every day when you drop something to the floor is the very force that holds the universe together. As we close this part of the story, let us imagine ourselves floating softly above the newborn star. We watch the glowing core, its first light spilling into darkness. Around it, the disk of gas and dust spins slowly, waiting to become planets. Above it, the nebula stretches far and wide, still birthing countless other stars. And through it all, gravity continues its timeless work, pulling, guiding, shaping, with patience and silence. The invisible hand of the universe, always present, always gentle, always strong. For millions of years, gravity has been gathering gas and dust, pulling it closer, pressing it tighter into the heart of a forming star. At first, the clump is dark, hidden within the nebula, a protostar, glowing faintly with warmth but not yet alive. It is like an infant, still in the womb, its heartbeat soft, its breath not yet taken. But inside, deep in the very core, something extraordinary is beginning to happen. The pressure has built to unimaginable levels. The temperature has climbed to millions of degrees. And the tiny hydrogen atoms, those same atoms drifting peacefully in the nebula long ago, are now pressed so close together that they can no longer remain apart. This is the moment when nuclear fusion begins. Two hydrogen atoms, each with their own proton, slam together with such force that they merge into one. In doing so, they create helium and release a burst of energy, light, heat, and power. It is a reaction so small, yet so powerful, that it fuels every star in the sky. Imagine striking a match. The flame begins as the smallest spark, but in that instant, the fire is alive. In the same way, the spark of fusion is like the first breath of a star. From this moment on, the star is no longer just a clump of gas. It has become a living sun, burning with its own fire, shining its own light, reaching out into the universe with brilliance. To grasp the scale of this energy, consider our own sun. Every second, it fuses over 600 million tons of hydrogen into helium. The energy released in that single second could power all of human civilization for millions of years. And yet, the sun has been doing this steadily for billions of years already and will continue for billions more, all from the spark that began when gravity pressed hydrogen together until fusion was possible. Fusion is the balancing act of the universe. Gravity pulls the star inward, but the energy from fusion pushes outward, creating a perfect harmony. This balance allows the star to shine steadily, not collapsing, not exploding, but glowing peacefully in the darkness. Without fusion, a star cannot exist. It is the very heartbeat of its life, the fire in its soul. If you could stand at the surface of a newborn star, you would see an ocean of glowing plasma, rising and falling like waves, immense storms of gas twisting across its face, and from its core, energy streaming outward, traveling for thousands of years, before finally reaching the surface to spill into space as light. The light we see tonight from distant stars in the sky may have left them hundreds, even thousands of years ago, and yet it all began with that single spark of fusion. It is humbling to remember that the warmth of the sun on your skin, the light of dawn spilling over the earth, the glow of the stars above you tonight, all of it comes from this same process. Hydrogen becoming helium, energy released into the cosmos, the quiet fire that keeps the universe alive. So in the stillness of the nebula, when the protostar finally ignites, a star takes its first true breath. It will shine for millions or billions of years, depending on its size. But the beginning is always the same: a spark, a whisper, a flame, born from the patience of gravity. Close your eyes for a moment and imagine the star, its heart burning with fusion, its surface glowing with waves of energy, its light spilling outward into the darkness of space. This is no ordinary fire. It is not like the flames of wood or the burning of coal. It is a fire without fuel, a fire of pure transformation. Hydrogen, the simplest element in the universe, is reshaped into helium, and in that reshaping, energy is released. But there is something beautiful, something delicate about this process. It is not wild. It is not uncontrolled. It is a balance. For as fusion pushes outward, gravity continues to pull inward. The two forces, one trying to compress, the other trying to expand, find a perfect harmony. This is the secret of the star's life. The steady glow we see in the sky is not stillness, but balance, a quiet negotiation between collapse and explosion. Think of a tightrope walker, balancing carefully with each step. Too far in one direction, they fall. Too far in the other, they tumble. And yet, step by step, they move forward, gracefully, steadily. A star is much the same. It does not collapse under its own weight, because fusion pushes back. It does not fly apart because gravity holds it in. Instead, it walks that invisible line. For millions, even billions of years, the sun is one of these stars, resting in its long middle years, shining steadily, fueled by the endless dance of fusion. Every second, it releases more energy than billions of nuclear bombs. Yet it feels calm, peaceful, even gentle. From our perspective on Earth, it rises and sets each day with quiet regularity. We rarely think of the titanic forces within it because its balance is so perfect, so stable. And yet, within the sun's core, fusion reactions happen every moment. Protons collide, hydrogen becomes helium, and in the process, a little mass is lost. This lost mass is not destroyed. Instead, it is transformed into energy. This is Einstein's famous insight. His equation, E equals mc squared. It tells us that even a tiny bit of matter can be turned into an immense amount of energy. And in the heart of every star, this truth is lived out endlessly. If you could shrink yourself and drift into the core of a star, you would see protons, the nuclei of hydrogen atoms, colliding at unimaginable speeds. Some would fuse together, releasing flashes of energy, tiny sparks in a sea of fire. These sparks combine, they ripple outward, and eventually they form the glow that reaches us across space. The sunlight that warms your skin, that allows plants to grow, that gives us life itself, is the end result of countless collisions of protons. In the sun's core, fusion is patient. It does not burn all the hydrogen at once. It proceeds slowly, steadily, like a candle meant to last the ages. This is why stars live so long. Though they shine with unimaginable brightness, they pace themselves, spending their fuel gradually, with care. A massive star will burn quickly, like a brilliant firework, bright but brief. A smaller star, like our sun, burns more gently, lasting billions of years. The balance of fusion and gravity is what allows the universe to sparkle with stars. Without fusion, gravity would crush every star into a lifeless ball. Without gravity, fusion would scatter the star into the void. Together, they form a partnership that sustains the light of the cosmos. And so, when you look at the night sky, you are witnessing harmony, a balance written into the fabric of the universe, a conversation between gravity and fusion, a dialogue that has lasted since the first stars and will continue until the last ones fade away. In the quiet of the universe, fusion is the hidden heartbeat. It is not loud. It is not violent. Instead, it is steady, patient, and endlessly generous. For without fusion, there would be no stars, no warmth, no light, and no world like ours. Let us think gently about what fusion has given us. The hydrogen that fills the stars is the oldest substance in existence, born in the first moments after the Big Bang. For billions of years, it floated freely, waiting patiently, until stars were born to gather it. Inside those stars, hydrogen began its transformation, becoming helium, and later, becoming heavier elements, carbon, oxygen, iron, the very building blocks of life. It is a humbling thought that every breath you take is possible because of fusion. The oxygen in your lungs, the carbon in your body, the calcium in your bones, all of it was made in stars. Carl Sagan once said, "We are made of star stuff." And in these soft, dreamy moments, we can feel the truth of it. fusion is not just a spark that lights the stars. It is the process that gave birth to us. And still, the story goes on. Every second, the sun fuses 600 million tons of hydrogen into helium. This sounds enormous, and it is. Yet the sun has so much fuel that it will continue shining for another 5 billion years. Think of that span of time, billions of sunrises and sunsets, billions of days filled with light, billions of nights lit softly by starlight. All of it made possible by the quiet persistence of fusion. In a way, fusion is the great caretaker. It ensures that planets can be warm enough, that water can flow, that life can grow. It creates the gentle stability that makes existence possible. When you walk beneath the sun or look up at the night sky, you are held in the embrace of fusion's gift. And yet, fusion is also temporary. One day, when the hydrogen in a star's core runs low, the delicate balance between gravity and fusion will shift. But that is a story for another time, a story of aging stars and their eventual fate. For now, let us simply rest with the knowledge that fusion burns quietly on, filling the universe with light, filling our world with life, filling our nights with stars. So the spark of nuclear fusion is more than just science. It is poetry written in the language of the cosmos. It is the slow, patient glow that transforms the dark into light. It is the eternal fire that kindles the stars and whispers to us across the vastness of space that we are not separate, but part of the same great unfolding story. When a star first ignites with fusion, it enters into a new stage of life. A calm, steady, enduring stage called the main sequence. This is the time when a star is at peace. It has found its balance between gravity pulling inward and fusion pushing outward. The two forces meet, not in struggle, but in harmony. Imagine the star resting in the cradle of space, its light steady and true. For millions, even billions of years, the star will remain in this stage, burning its hydrogen gently, glowing with constant warmth. The main sequence is like the long middle years of life. It is not the frantic beginning, when a star is born in clouds of dust, nor the dramatic ending when a star collapses or explodes. It is the quiet chapter in between, where stability reigns. A chapter so long that most of the stars we see in the night sky are living through it right now. Our own sun is a main sequence star. It has been glowing like this for about 4.6 billion years, and it will continue for another 5 billion years still. Think about that span of time, all of human history, every story ever told. Every step taken by humankind has unfolded under the calm light of a main sequence sun. And long after we are gone, long after civilizations have risen and faded, the sun will continue to shine, just as it does today. In this stage, a star is like a great hearth fire. It does not flicker wildly. It does not threaten to go out. It burns evenly, casting a steady glow, nurturing whatever may circle around it. Around our sun, planets formed, and life emerged. All of it was made possible because the sun is steady, because it lives in the long calm of the main sequence. If you could look across the galaxy, you would see billions of stars, most of them quietly existing in this same way. Some are larger and brighter, others are smaller and dimmer, but all of them, in their main sequence, are like candles burning patiently. keeping the darkness at bay. This is why the main sequence is sometimes called the golden age of a star. It is the time when everything is balanced, when the star is at its most reliable, when it gives its light generously to the cosmos around it. But not all main sequence stars are the same. Some live quickly, others live slowly. A massive star, 10 times the size of the sun, burns much hotter, much brighter. But because of this, it uses its fuel more quickly. Its main sequence may last only a few million years. A smaller star, like a red dwarf, burns very slowly, so slowly that it can last for trillions of years. These stars may outlive the universe itself, continuing their quiet glow long after brighter stars have faded away. And so, the length of a star's main sequence is written in its birth. A star's size, its mass, decides how long it will live in this cometal stage. The sun is medium-sized, so its main sequence is measured in billions of years. But every star, whether small or large, cherishes this stage because it is the time of balance, the time of stability, the time of light. The main sequence is also the stage we know best because it is what we see. When you look at the sky at night, nearly every twinkling star you notice is in its main sequence. Their light has traveled for years or centuries or even millennia to reach your eyes. And in that moment, you are looking not at a beginning and not at an ending, but at a star in its prime, living out its long, steady life, glowing quietly in the universe. So the main sequence is the time when a star truly is. It is not rushing toward change. It is not bracing for collapse. It is simply being, glowing, existing, and giving. It is a star's great offering to the cosmos, a steady light, a dependable warmth, a gentle rhythm of energy that may last for longer than we can truly imagine. Not all stars live the same kind of main sequence life. Some live quickly, fiercely, others live slowly, patiently, and the difference comes down to their size. A star's mass, the amount of material it gathered at birth, decides everything about how it will shine and how long it will last. A massive star, one that might be 10 or even 50 times larger than our sun, lives a short, dazzling life. Its hydrogen fuel is burned so quickly that its main sequence may last only a few million years. To us, a million years sounds vast, but for a star, it is just a brief spark. These stars shine so brightly that they outshine thousands of smaller stars around them. They are the beacons of the galaxy, lighting up distant regions with their brilliance. But like a candle that burns too fiercely, they do not last long. They pour all their energy outward, living boldly, but briefly. Now imagine the opposite, the small red dwarf stars. They are tiny compared to the sun, sometimes just a tenth of its size. Their glow is faint, a soft red light, barely visible to the naked eye from far away. Yet their smallness gives them a gift. They burn their fuel very slowly, so slowly that they may last for trillions of years. Think of that number, 1,000,000,000,000 years, 1,000 times longer than the universe has existed so far. These little stars will likely be the last lights to fade. Long after all the brighter ones are gone, they will remain, flickering softly, the eternal embers of the cosmos. And then there are stars like our sun, medium in size, medium in brightness, not rushing like the giants, and not lingering endlessly like the dwarfs. Our sun's main sequence lasts around 10 billion years. That span of time is generous enough to nurture planets, to allow life to form, to let evolution unfold at its gentle pace. It is as if the sun was made to be steady enough, long enough for Earth's story to happen. So you see, the main sequence is not the same for every star. It stretches or shortens, depending on size. Some stars shine like fireworks, brilliant but brief. Others are like quiet coals, steady and nearly eternal. Together, they weave the fabric of the galaxy. Some bring bursts of light to distant skies. Others keep a slow glow alive through unimaginable spans of time. But whether short or long, bright or faint, all stars in the main sequence share one truth. They are stable. They are balanced. They are giving their light to the space around them. And in that balance, in that steady giving, they create the conditions for worlds, and for life, and for wonder. As you look up at the stars tonight, you may notice their different colors, some shining blue and bright, others glowing red and soft, some yellow like our sun. Those colors are hints of their temperature and of their size. The bluest stars are the hottest and the most massive. They will live quickly and die dramatically. The reddest stars are the smallest and coolest. They will live the longest and fade the slowest. And in between, the golden stars like our sun shine steadily, just long enough for stories like ours to unfold. This diversity of stars, large and small, is what makes the night sky so rich. Each point of light you see is not only a star, but a story of balance, a story of fuel and time, a story of a life lived according to its size. And all of these stories are happening together right now across the galaxy. Imagine floating near a star like our sun, not too close, just far enough to feel the warmth on your skin and the soft golden light on your face. This is the life of a star in its main sequence. Balanced, steady, a cosmic heartbeat that has been pulsing for billions of years. At the very center of the star, fusion continues its quiet work. Hydrogen atoms collide and merge, becoming helium, and in that union, they release light and heat. This process does not rush. It does not stumble. It is gentle, constant, and incredibly precise. Every second, billions upon billions of reactions occur, each one a tiny spark, each one contributing to the whole. Together, they create the warm glow that fills the universe, and the quiet energy that keeps the star alive. But fusion alone is not the secret. The true magic is in the balance. On one side, gravity pulls inward, always trying to make the star collapse. On the other side, the energy of fusion pushes outward, gently resisting, holding the star open. This dance of forces is what makes the main sequence so stable. Neither side wins, neither side loses. Instead, they hold each other in perfect harmony. It is a little like breathing. Inhale, exhale, inward, outward, a rhythm that continues quietly without needing to be forced. The star breathes in its own way, gravity pulling inward, fusion pushing outward, a balance as natural as life itself. Inside the star's layers, the energy created in the core slowly makes its way outward. But this journey is not quick. A single particle of light born in the star's heart may take thousands, even millions of years to escape into space. It bounces around endlessly, absorbed, released, absorbed again. A long, patient journey through the dense layers of plasma. And yet, eventually, it reaches the surface. And in that moment, it shines outward into the universe, perhaps falling one day onto the earth and onto your face as sunlight. Think of this for a moment. The sunlight that warms you today may have begun its journey inside the sun millions of years ago. It wandered in darkness. It struggled through the dense layers. It waited and then finally escaped into the open to shine upon you. What patience, what dedication, what quiet devotion for a single ray of light to find its way to you. This is what a main sequence star does every day, every year, for billions of years. It shines not hurriedly, not desperately, but steadily, as if whispering, I am here. I will keep you warm. I will give you light. And all across the sky, millions of other stars are doing the same, each one a quiet lamp, burning softly in the cosmic night, each one living its main sequence life, balanced and calm, a steady rhythm, a steady heartbeat. When you gaze at the stars tonight, perhaps you can feel that rhythm, the balance between gravity and fusion, the patience of light traveling across the cosmos, the harmony of forces that creates warmth and life. The main sequence is not a frantic time for a star. It is its long, peaceful middle age, its time of stability, its time of giving. And in that giving, we are blessed. So as we close this part, let us hold the image of a star, steady balance, burning softly across the ages. It is not in a hurry. It does not falter. It simply shines, faithfully, patiently, endlessly. And in that light, we find warmth. We find life. We find wonder. Close your eyes and picture the night sky, a velvet canvas sprinkled with countless lights. Each point of light looks so similar, yet hidden within are vast differences. Some stars are giants, swelling with power and heat, so massive that their light burns bright, but their lives are short. Others are small, quiet, gentle in their glow, living long, patient lives, stretching across the ages. In the universe, a star's journey is written not in its color, not in its position, but in its size. The mass it is born with becomes the compass of its destiny. A small star, perhaps only a fraction of the sun's mass, will shine faintly, burning its fuel slowly, carefully, as though it knows it must save its strength. These stars, called red dwarfs, are the most common of all. They do not dazzle with brilliance, yet they live unimaginably long lives, billions, even trillions of years. They are the quiet keepers of the cosmos, enduring long after brighter stars have vanished. Now imagine a star larger than the sun, born with more mass. It burns faster, fiercer, its heart raging with nuclear fire. These stars blaze with white or blue light, so powerful that their radiance can be seen from great distances. And yet, this brilliance is not everlasting. For all their strength, large stars live brief lives. Some last only millions of years, a mere breath compared to the vastness of time. Like a flame that burns too brightly, they use up their fuel quickly, and their end comes sooner. Think of it like candles. A small candle burns softly, slowly, lasting through the long night. A tall, wide candle burns fiercely, its flame larger, brighter, but it melts away in half the time. Stars are much the same. The greater the mass, the brighter the flame, and the shorter the life in the stillness of the universe. This balance of size and time creates a beautiful diversity. Tiny red dwarfs that linger forever, medium stars like our sun, steady and reliable for billions of years, and massive stars whose short but dazzling lives end in spectacular fashion. Every star, large or small, follows the path that its size has written for it. And in that quiet truth, we find a lesson that brilliance is not always in brightness. Sometimes it is in patience. Sometimes it is in endurance. So as you look at the sky, know that each star you see carries its own story, a journey shaped by the weight of its birth, a journey unlike any other. Some are racing through life, others are strolling gently, but all are moving, all are alive, all are part of the universe's great, unfolding song. When stars are young, their lives seem similar. They all shine with steady light, balance between gravity pulling inward and fusion pushing outward. But as they grow older, the differences in size become more and more important. Like children growing into adults, their paths begin to diverge, each shaped by the strength they were born with. Let us begin with the smallest stars, the red dwarfs. These stars sip at their fuel, burning hydrogen with incredible care. Because of this, they age so slowly that none have yet reached old age. The universe itself is not old enough to see a red dwarf die. Every red dwarf ever born still glows today. Someday, trillions of years from now, they will fade into quiet embers. But for now, they remain eternal companions of the cosmos. Now, picture a star like our sun, a middle-sized star. It lives faster than the red dwarf, but still patiently for billions of years. Slowly, gently, it uses up the hydrogen in its core. When that fuel runs low, the sun will begin to change. Its core will contract, its outer layers will swell, and it will grow into a red giant. This is the destiny of medium stars, to live long, steady lives, and then expand in their old age, glowing larger and cooler before gently fading. But the story is very different for the giant of the cosmos. Massive stars live so fiercely that they reach old age in just a few million years. Their cores run hot, too hot, burning through hydrogen in a furious rush. When hydrogen runs out, they do not simply swell gently like the sun. Instead, they begin to fuse heavier elements, helium, carbon, oxygen, each stage shorter and more violent than the last. Their lives are like storms, rushing toward a dramatic end. And when they finally collapse, they will explode in a brilliant supernova, a death as spectacular as their lives. So we see a red dwarf lingers, a sun-like star grows old and swells. A massive star lives fast and dies young. Their paths are different, but each is beautiful. Each plays a role in the great balance of the universe. It is almost as though the cosmos itself wanted variety. Some stars to last, others to dazzle, others to quietly endure. Without this balance, our universe would look very different. There would be no brilliant supernovae, no long-lived embers, no stable stars like the sun to nurture life. The different journeys of stars, are not accidents. They are the heart of creation itself. So as you gaze upward, remember, you are not seeing just one kind of star. You are looking at lives unfolding on many different paths, some at the very beginning, some in their long middle years, some racing toward a dramatic end, and each of them is part of the same story, the story of light, born from darkness and shining across the ages. If you close your eyes for a moment and imagine the night sky stretching endlessly above you, you may feel that every star is the same, just tiny specks of white light. But in truth, each one is carrying a story, a destiny set long ago, and a quiet lesson for us here on Earth. The small stars, those faint red dwarfs, teach us about patience. They live slowly, conserving their strength, never rushing, never burning too fast. Their lives remind us that sometimes endurance is more powerful than brilliance. They do not shine the brightest, but they shine the longest. A reminder that steady effort across time outlasts sudden bursts of energy. The medium stars, like our own sun, teach us about balance. They burn bright enough to warm their planets, but not so fiercely that they vanish too soon. Their journeys last billions of years, long enough for life to grow, long enough for stories to unfold. Our sun is such a star, a calm, steady companion, holding Earth gently in its warmth. It reminds us that balance is a gift, that too much or too little can change everything. And then there are the massive stars, the great giants of the cosmos. They live with intensity, with passion, burning their fuel in a great, dazzling blaze. They remind us that brilliance has its place too, that even a short life can leave a lasting mark. For when these giants die, they do not fade quietly. They explode, spreading heavy elements across the cosmos, the very elements that make planets, oceans, and even our own bodies. Without their sacrifice, there would be no earth, no water, no life. So we learn from the stars that there is no single right way to live. Some lives are long and steady, some are balanced and nurturing, some are short but transformative. The universe makes room for them all, and from each, something beautiful is given. Perhaps this is why people have always looked to the stars for guidance. They do not speak with words, but with light. They shine across the darkness, telling us quietly that there are many ways to live, and all are meaningful. So tonight, as you drift towards sleep, let the stars remind you that your own path, like theirs, is unique. Whether you move slowly, steadily, or burn brightly, your light matters. And like the stars, your journey is part of something vast and beautiful, woven into the story of a universe itself. Every life, whether it belongs to a person, a tree, or a star, has its seasons. There's a time of birth, a time of youth, a time of maturity, and eventually a time of aging. Stars, too, follow this gentle rhythm, though their lives last millions, even billions of years. They cannot shine forever. And when the first signs of age appear, it begins with something invisible to the eye, deep in the hidden heart of the star. At the center of a star, fusion is a fire that keeps it alive. For most of a star's life, this fire is steady and strong. Hydrogen atoms fuse together, becoming helium, releasing light and warmth that streams out across the universe. But with time, the hydrogen supply begins to run low. Slowly, almost imperceptibly, The balance that once held the star steady begins to change. Gravity presses inward harder. The core grows hotter and denser, and new processes begin to stir. It is as if the star is taking its first deep sigh of old age, a shift subtle but certain. Imagine the sun, for example. For nearly 4.6 billion years, it has burned steadily, a faithful companion, giving life to Earth. But even the sun will not remain the same forever. Billions of years from now, its hydrogen supply will dwindle, the core will contract, heating up more and more, while the outer layers begin to expand outward. The sun will grow larger, brighter, and cooler on the surface, becoming a red giant. From Earth's perspective, the gentle yellow star we know will look swollen, crimson, and strange. It will be the beginning of its old age. And yet, there is something deeply beautiful in this stage of life. Stars do not collapse into darkness right away. They evolve slowly, gracefully, changing their colors, their shapes, and their energy. In this way, they remind us of the trees in autumn, when leaves turn red and gold. They are not ending suddenly. They are changing into something new, something striking and unforgettable. Aging, even for stars, is not simply loss. It is transformation. As we watch stars in this stage, we are really witnessing the quiet truth of time. Nothing remains as it is forever, and yet each change brings a new form of beauty. The red giant stars scattered across the night sky are like cosmic elders, glowing with a softer, whiter light, whispering stories of long lives lived. And the changes still come. When the steady supply of hydrogen in a star's core begins to run low, a great change awakens. For most of its life, hydrogen has been a quiet fuel, keeping the balance between outward light and inward gravity. But once that fuel dwindles, the delicate balance begins to tremble. Gravity pulls harder, pressing the core inward, and as the core contracts, it grows hotter, much hotter than before. It is as though the star is bracing itself, gathering its last great reserves of energy. The outer layers, no longer held as tightly, begin to drift outward. The star swells, growing larger and larger, until it is many times its original size. The surface cools as it stretches, turning from bright white or yellow to a softer reddish glow. This is the red giant phase. From afar, a red giant looks majestic, vast and glowing, yet gentle in its light. To the human eye, it may seem peaceful, but deep inside, the star is struggling, changing, and beginning to write its final chapters. Inside the contracting core, something new begins. With the rising heat and pressure, helium, once just the ash of hydrogen fusion, begins to fuse itself. Helium atoms merge to form carbon and sometimes oxygen. This process releases energy, though not as steadily as hydrogen did. The star's light becomes less stable, flickering between quiet moments and bursts of activity. Sometimes the star swells further, then shrinks back slightly, as if it is breathing heavily in its old age. These stages can last millions of years, or just a few 100,000, depending on the star's size. For a human, it would be like watching decades of change compressed into a few moments of cosmic time. For our sun, this swelling will be dramatic. One day, billions of years from now, its outer layers will expand so greatly that they will reach out to Mercury, then Venus, and possibly even Earth. The warm, golden sun we know will become an enormous red giant, filling much of the inner solar system with its vast, glowing body. It is a strange thought to imagine the sky filled not by a small, bright disk, but by a red, swollen giant, covering half the horizon. In these moments, stars remind us of life's impermanence. What feels eternal is in truth always moving, always changing. The constellations we see tonight, the stars we wish upon, even they are aging, moving through their quiet transformations. Some are swelling now. Others will swell long after humanity has passed. But all of them are following this universal path, from youth to maturity to a graceful old age. And so, the red giant phase is not an ending, but a transition, a star shifting into a new form, preparing for the next stage in its remarkable journey. As a star drifts deeper into its old age, its life becomes less steady, more fragile. The smooth balance it once held, the quiet dance between fusion and gravity, begins to unravel. The fire in its heart flickers, brightening, fading, brightening again, as if the star is taking its final breaths. Inside, the helium that once fused into carbon and oxygen may itself run out. When this happens, the core contract again, heating even more, searching desperately for something new to burn. For massive stars, the temperatures may rise high enough to fuse heavier elements. Carbon into neon, oxygen into silicon, silicon into iron. Each step takes enormous energy, and each step grows shorter, faster, like the final second of a candle burning down. But for stars the size of our sun, the process stops with helium. The star cannot reach the extreme temperatures needed for heavier fusion. Instead, its core contracts into a dense ball of carbon and oxygen, while the outer layers continue to swell, flicker, and pulse. The outer atmosphere becomes unstable. Layers of gas drift away, carried off into surrounding space like veils of mist. The star coughs and shudders, releasing streams of matter into the cosmos. From afar, these outbursts can be breathtaking. The star is wrapped in glowing shells of gas, illuminated by its fading core, a soft, ethereal light that astronomers call a planetary nebula. These shimmering clouds float outward, slowly expanding, glowing in colors of green, pink, and blue, a final gift to the universe. Meanwhile, the core, once the furnace of life, grows small, dense, and faint. It becomes a white dwarf, a star's quiet ember, hot, but no longer burning fuel, shining weakly with the leftover heat of its long journey. This is how a small star ages, fading slowly over billions of years until it cools into darkness. It is a peaceful ending, quiet and soft. Massive stars, though, live a far more dramatic old age. Their cores burn through new fuels rapidly, one after another, until finally iron builds up. And iron, unlike other elements, does not release energy when fused. It is a dead weight that ends a massive star's life. When the iron core can no longer resist gravity, it collapses in an instant, a collapse so violent that it triggers a supernova explosion. The outer layers are hurled into space, brighter than an entire galaxy for a brief time. It is the most dramatic finale in all of nature, a star's last blaze of glory before the end. Whether quietly as a white dwarf or violently as a supernova, every star shows us that aging is not an erasure, but a transformation. Each star leaves behind traces, glowing clouds, scattered elements, collapsed remnants that will shape the next generation of stars and worlds. Even in its final stages, a star gives back to the universe. And perhaps in that, there's a lesson for us too. Small stars, like our sun, live long and steady lives. For billions of years, they shine softly, fueled by the quiet fusion of hydrogen into helium. Unlike their massive, fiery cousin, they are calm, dependable, almost eternal to human eye. But even for these gentle suns, time flows on, and when their hydrogen fuel runs low, their lives begin to change. The first step, as we've seen, is the red giant phase. The star swells outward, glowing with a cool red light. Its outer layers stretch thin, its inner core compressed tight. It breathes heavily in these years, pulsing and flickering, as though trying to hold on to its familiar rhythm. But the helium in its heart cannot last forever. When it, too, is gone, the star has no new source of fire. Gravity presses in, the outer layers drift away, and the long journey begins to close. From Earth, if we could watch our sun's final chapters, it would be a strange sight. The sun would expand so greatly that its swollen body might reach the orbit of Earth itself. The skies would glow red, and the warmth of the sun would grow unbearable until Earth, like Mercury and Venus before it, is swallowed by its parent star. But this violent image is only part of the truth. For in the star's heart, the final stages are quiet, graceful, a slow release of light and matter. The outer layers, loosened by instability, drift into space, a soft exhale of gas and dust. They form delicate, glowing shells that float outward, becoming what astronomers call a planetary nebula. These nebulae are not planets at all, but luminous clouds, glowing softly with the last light of the star within. Seen through telescopes, they appear as rings, bubbles, or wisps of color, green, blue, pink, or violet. Each one unique, each one a star's farewell letter to the cosmos. At the center of this fading glow rests the core, small, dense, and brilliant. It shines not with new fusion, but with the last stored heat of its long past. This remnant is called a white dwarf, a star's quiet ember. A white dwarf is astonishingly dense. Imagine something the size of Earth, yet as heavy as the sun. A teaspoon of its matter would weigh as much as a mountain. It is the heart of the star, compressed into silence. And yet, though silent, it still glows. For billions of years, it shines faintly, slowly cooling, slowly fading. Eventually, it becomes a black dwarf, a dark, cold star, no longer visible. Though the universe is not yet old enough for any white dwarf to have reached this stage. Every white dwarf that has ever formed still glows, somewhere in the dark. The death of a small star is not sudden, not explosive, but slow, gentle, and luminous. It is less like a firework, and more like a lantern, burning lower, dimmer, until finally the light fades away. At the very heart of every small star's ending lies the white dwarf. It is not fiery nor unstable. It is silent, enduring, and astonishingly strange. A white dwarf is what remains after a small star has shed its outer layers. Imagine the star's vast body, collapse into something no larger than Earth, yet still containing nearly all the sun's mass. This tiny, dense remnant is left glowing in the darkness, like an ember cooling after a great fire. The physics of a white dwarf is unlike anything we know in our daily lives. Here on Earth, matter is arranged in atoms, empty space between a tiny nucleus and its orbiting electrons. But in a white dwarf, gravity has squeezed matter so tightly that this empty space is gone. Electrons are pressed close together, resisting further collapse by a quantum law called electron degeneracy pressure. It is this invisible pressure, born not from heat, but from the very rules of quantum mechanics, that holds up the white dwarf against gravity's pull. Without it, the star would collapse even further, into something darker and stranger still. White dwarfs glow with residual heat, but no longer create energy through fusion. Slowly, over billions of years, they radiate away their warmth. They cool, first shining white, then yellow, then red, until at last, in unimaginable time, they would fade to black. Astronomers call this the black dwarf stage. But the universe is still too young for black dwarfs to exist. Even the oldest white dwarfs, formed more than 12 billion years ago, are still glowing faintly. Every white dwarf is still a candle in the dark. No ember has fully gone out. From Earth, white dwarfs appear small, faint, and elusive, but their influence is profound. Many are found in binary systems, orbiting close to another star. In some cases, they siphon matter from their companions, a slow trickle of gas that spirals down onto their surface. When enough matter piles on, the pressure can ignite a sudden burst of fusion on the white dwarf surface. This creates a brief, brilliant flare called a nova, a star that seems to brighten overnight, then fade again. In rarer cases, if a white dwarf gathers too much mass, it may collapse completely, triggering a Type Ia supernova. These explosions are so uniform in brightness that astronomers use them as standard candles to measure the distances of galaxies across the universe. So, though white dwarfs may seem like endings, they are also beginnings. Their quiet glow provides us with clues to the age of the galaxy. Their rare explosions seed the cosmos with new elements. Their presence tells the story of stars that once shone, long before our sun was born. A white dwarf is a paradox. It is small but immense, dead but still glowing, silent but still speaking across the cosmos. It is the final stage of most stars, a reminder that even in death there is beauty, and even in silence there is meaning. The story of a small star does not end quickly, even after its final breath as a red giant, even after its outer layers drift away into glowing nebulae. Its white dwarf heart remains, shining faintly, slowly cooling. But time in the universe moves on scales far beyond our imagination. Billions of years pass, and still the white dwarf glows. Its light dims, but does not vanish. Its heat wanes, but never quite disappears. To us, these timescales are longer than eternity. The Earth is only 4.5 billion years old. Yet a white dwarf may shine quietly for many tens of billions more. In the far future, when galaxies themselves are older and dimmer, when stars no longer form as they do today, these white dwarfs will still be here, scattered like ancient embers across the night. But eventually, their stored heat will fade. Their glow will vanish. They will become dark, invisible remnants called black dwarfs. A black dwarf is a star that no longer shines. It is not hot, not bright, not even visible. It is, in every way, a star that has fallen fully asleep. And yet, as of now, the universe is not old enough for black dwarfs to exist. Every white dwarf we see is still glowing faintly. Every ember is still alive. To imagine black dwarfs, we must imagine a universe trillions of years older than today. A universe so ancient that our Milky Way may have merged with other galaxies, so vast in time that even the stars we know will be forgotten. And in that quiet future, the dark skeletons of once bright stars will drift unseen, their surfaces cold, their hearts silent, their stories finished. But perhaps their silence is not the end, because even in death, these black dwarfs will still shape the universe. Their gravity will still pull, still orbit, still dance among the stars that remain. And their very presence will be a reminder that once, long ago, they burned bright. The matter that once glowed in their nebulae will live on in new stars, new planets, perhaps even in life. The cycle of stars will continue, even if the embers themselves are dark. The death of small stars is a lesson in patience. It is not an explosion, but a fading, not a violent shout, but a whisper that lasts for eternity. From the first spark of hydrogen fusion to the final silence of a black dwarf, a small star lives a life of endurance, beauty, and grace. It reminds us that even the quietest lives, even the slowest journeys, have meaning, and that in the long unfolding of the cosmos, endings are never truly final. They are simply transformations, preparing the way for something new. Massive stars live very different lives from their smaller, gentler cousins. Where the sun burns steadily and calmly, massive stars burn with intensity, their lives bright but brief. Imagine a star 10, 20, even 100 times the mass of our sun. Its gravity is immense, pressing inward with crushing force. To resist that pull, its core must burn hotter and faster, fusing hydrogen into helium at a furious rate. The result is a star so luminous it can shine millions of times brighter than the sun. But with a cost, its fuel is used up astonishingly quickly. A small star like our sun may live for 10 billion years, but a massive star, it may last only a few million. In cosmic terms, it is a candle burning at both ends, dazzling in brightness, but destined to fade in a cosmic blink. As it ages, a massive star swells and changes color. Its core fuses not only hydrogen, but heavier and heavier elements. Helium into carbon, carbon into oxygen, oxygen into silicon and beyond. Each step produces less energy than the last, leaving the star closer to collapse. Eventually, in its heart, the star creates iron, and here lies the turning point. Iron cannot be fused to release energy. It only consumes it. When a star's core fills with iron, it has reached the end of its ability to resist gravity. The outward pressure that once balanced the star is gone. In an instant, the delicate balance of forces breaks. The massive star teeters on the edge of destruction, its fate sealed. From Earth, such stars may appear calm and constant, but inside, they are roaring furnaces, burning through their lives in haste, destined for a spectacular finale. Unlike small stars that fade quietly, massive stars do not go gently. They go with brilliance, with violence, with power enough to shape the galaxy itself. Inside a massive star, the heart of iron grows heavy, silent, and unstable. No more fusion can occur. No more energy can be released to push back against the crushing pull of gravity. And then, in less than a heartbeat, the inevitable begins. The core collapses. It falls inward at incredible speed, faster than light can cross a room. The atoms themselves are crushed, electrons forced into protons, creating neutrons. The core shrinks into something unimaginably dense, a ball no larger than a city, yet heavier than our entire sun. This collapse sends a shockwave outward, slamming into the star's outer layers. The star, which has burned for millions of years, erupts in a moment of unimaginable violence. This is a supernova, a titanic explosion, brighter than all the billions of stars in its galaxy combined. For weeks, it outshines everything else in the night sky. From Earth, a supernova can be seen across millions of light years, appearing like a sudden new star. Ancient astronomers recorded these events in awe, calling them guest stars, not knowing they were witnessing the death cries of suns far larger than their own. The force of the explosion hurls the star's outer layers into space at astonishing speeds. Hydrogen, helium, carbon, oxygen, gold, and uranium, the building blocks of planets, of oceans, of life, are scattered across the cosmos. In the silence that follows, the star is gone, Its brilliance lingers only in the glowing nebula it leaves behind, a cloud of color and light that will drift and shimmer for thousands of years. The Crab Nebula, for example, is the ghostly remnant of a supernova seen by humans in the year 1054. Even now, its filaments of glowing gas stretch through space, carrying the story of that star's final breath. But at the heart of the explosion, something new is born. Sometimes it is a neutron star, a city-sized sphere of pure neutrons, so dense that a teaspoon of material would weigh more than Mount Everest. Other times, if the star was truly colossal, its collapse is unstoppable, forming a black hole, a place where even light cannot escape. Thus, the death of a massive star is not truly an ending, but a transformation. It is the universe's way of recycling, of spreading elements across the stars, of creating the seeds for new worlds. The supernova is both destruction and creation. It is chaos and beauty combined. And it is through such explosions that we and everything we know were made. The iron in our blood, the calcium in our bones, the gold in our jewelry, all were born in stars that died this way. When the brilliance of a supernova fades, what remains is stranger, denser, and more enigmatic than the star that came before. At the heart of the chaos, a remnant is left behind, and its nature depends on the weight of the star that died. If the star was merely massive but not extreme, the collapse leaves behind a neutron star. Imagine an object no larger than a city, yet weighing more than our sun. Its gravity is so fierce that the matter inside has been squeezed into pure neutrons, particles normally tucked away inside atomic nuclei, now packed side by side like grains of sand on an infinite beach. To stand on such a star, if one could, would be impossible. A single step would crush you instantly. A teaspoon of a material would outweigh mountains, even continents. It is one of the densest forms of matter the universe allows. Some neutron stars spin rapidly, sending out beams of radiation that sweep across the cosmos like cosmic lighthouses. We call them pulsars, and when their beams pass Earth, we detect them as regular, rhythmic flashes, as steady as the ticking of a clock. Even from such catastrophic death, there is order, rhythm, and beauty. But sometimes the star was too massive, too heavy, too extreme for even neutrons to resist. In this case, gravity wins completely. The collapse continues, crushing matter beyond recognition, past the point where physics as we know it can intervene. And so, a black hole is born, a place where matter is compressed into a singularity, a point of infinite density, hidden within an event horizon, the invisible boundary from which not even light can escape. To an outside observer, the star is gone, replaced by an invisible darkness. Yet its gravity still lingers, pulling at nearby stars, bending the fabric of space itself. Though terrifying in thought, black holes are not villains of the cosmos. They are natural outcomes of life and death among the stars. Some even play roles in shaping galaxies, anchoring their centers with immense gravitational might. And so, the final fate of a massive star may be a quiet neutron star, endlessly spinning, or a silent black hole hidden in the dark, both reminders of the power and mystery of the universe. From gentle starlight to violent explosion to the creation of objects so strange we can scarcely imagine them, the death of a massive star is one of the universe's most astonishing stories. It reminds us that endings can be beginnings, that from destruction comes beauty, and that even in darkness, the cosmos is never truly silent. When a massive star dies, it does not vanish quietly into the night. Instead, it leaves behind gifts, pieces of itself scattered across the cosmos, drifting gently through the interstellar sea. The violent explosion of a supernova casts the star's outer layers far into space. Clouds of glowing gas and dust stretch outward, forming intricate patterns that shimmer and evolve over thousands, even millions of years. These glowing remnants are called supernova remnants, and they become some of the most beautiful sights in the universe. One such remnant, the Veil Nebula, looks like a delicate lacework of color, a thin veil of gas stretched across space, softly glowing in shades of blue, pink, and gold. Another, the famous Crab Nebula, still glows with energy, its filaments twisting and expanding like threads of cosmic silk, nearly 1,000 years after the explosion that created it. These remains are not just beautiful. They are important, because within these clouds of debris lie the heavy elements forged in the star's heart. Carbon, which forms the backbone of all living things. Oxygen, which fills our lungs with every breath. Iron, flowing through our blood. Even gold and silver, shimmering in jewelry and art. Every atom of these elements was born in the fiery death throes of a massive star. Scattered into space, they wait patiently to be woven into something new. Over time, these clouds drift, collide, and mix with other gas and dust in the galaxy. They enrich the interstellar medium, the vast ocean of material between stars. What was once part of a single, shining sun now becomes part of the galaxy itself, spread wide, waiting for the next chapter of creation. And so, the end of one star is never truly the end. Its remains become the seeds of something more, a quiet aftermath that whispers of future beginnings. The scattered remnants of a star do not wander aimlessly forever. In the stillness of the cosmos, gravity continues its quiet work, pulling, gathering, and weaving the debris into something new. Imagine vast clouds of gas and dust, gently swirling across space. They collide softly, merging into glowing nebulae, rich with color and life-giving elements. These nebulae are the cradles of future stars, nurseries where new suns will ignite. Within them, tiny ripples of density form, slight gatherings of material, almost invisible at first. But gravity, ever patient, slowly amplifies these ripples. The cloud darkens, cools, and contracts. And in time, a spark of light emerges, a newborn star. From the ashes of one sun, another rises. Its birth is not just a continuation of the cosmic story, but the direct result of the life and death that came before. The oxygen you breathe, the calcium in your bones, the iron in your blood, all came from such ancient cycles, passed down from generations of stars. Around these newborn stars, disks of gas and dust form. They swirl and coalesce, gradually giving rise to planets, moons, comets, and asteroids. Some of these worlds may remain barren, quiet, and cold, but others, if conditions are just right, may blossom into places where oceans form, where skies stretch wide, and where life might someday awaken. This is the quiet promise hidden within the aftermath of stellar death. That destruction leads to renewal, that endings become beginnings, and that the universe continually recycles itself, shaping beauty out of loss. The quiet scattering of a star's remains may seem distant, far removed from us, but in truth, those cosmic remnants live within us, here and now. Billions of years ago, long before Earth existed, ancient stars lived, burned, and died. They exploded in brilliant supernovae, casting their ashes across the galaxy. Those ashes drifted, gathered, and formed the clouds that would one day give birth to our solar system. The sun was born from that cloud. The planets condensed from the same material, and the Earth itself carries within it the elements forged in stellar hearts. Look down at your hands, the calcium in your bones, the iron in your blood. the oxygen filling your lungs with every breath. All of it was created in stars that lived and died long ago. You are, in the most literal sense, a child of the cosmos. Carl Sagan once captured it beautifully. We are made of star stuff, and in these words lies a gentle truth, that we are not separate from the universe, but born of it, shaped by it, and forever connected to it. Even the tiniest details of our lives reflect this connection. The gold in a wedding ring, the silver in a necklace, the carbon that makes life possible, all were gifts of dying stars. So, when you gaze up at the night sky, remember, you are not merely looking at distant suns. You are looking at your own family history, the ancestors that burned, lived, and died so that you could exist. The aftermath of stars is not just a scattering of matter. It is the foundation of everything we know and love. It is the reason Earth exists, the reason life thrives, the reason we can look up in wonder and tell these stories beneath the stars. The universe, vast and quiet, follows a rhythm, a pattern of birth, growth, death, and renewal. It is a cycle without end, a song that has been playing since the very beginning of time. We have seen how stars are born in clouds of dust, how they live brilliant lives powered by the gentle spark of fusion, and how they die, scattering their ashes across the galaxy. Yet this is never a true ending, for the matter that remains does not disappear. It simply waits patiently for the next chapter. Imagine the universe as a great cosmic garden. Stars are its flowers, blooming brightly for a time. When their petals fall, they enrich the soil so that new blossoms may grow even stronger, even more beautiful. This is the way of the cosmos. What is lost becomes a foundation of what is to come. A star that dies today may give rise, billions of years from now, to a planet where oceans shimmer, where winds whisper across mountains, and where life may someday look up at the stars in awe. The cycle continues not only in the skies above, but in us here on Earth. Every heartbeat, every breath, every thought in your mind, all are built from the remnants of ancient stars. Their lives and deaths echo within you, reminding you that you are part of something vast, timeless, and unbroken. And so, the story of stars is not just about the heavens. It is about us. It is about continuity, connection, and belonging. It is a soft reminder that in this endless cycle, you are never truly alone, because you carry the universe within you. The life and death of stars do not happen in isolation. They are threads in a grander tapestry, woven across the vastness of galaxies. Each galaxy, with its billions of stars, is a living system. Within its swirling arms, stars are born in glowing nurseries, while others age, fade, and die, returning their essence to the galactic sea. It is in this continuous weaving, this giving and receiving, that galaxies maintain their brilliance. They are not static structures, but dynamic, ever-changing, ever-renewing homes for countless suns. Now imagine this on an even larger scale. Galaxies themselves form, evolve, and interact. They collide softly over billions of years, their stars dancing together, their clouds merging, their cycles of birth and death feeding into one another. The Milky Way, our home galaxy, is currently on a slow and graceful path toward its neighbor Andromeda. In several billion years, the two will merge, creating a new, larger galaxy, one filled with new opportunities for stars to be born and new worlds to be shaped. Even here, the cycle continues. Galaxies die into galaxies, just as stars die into stars. And beyond galaxies lies the universe itself, An endless sea of cycles layered upon cycles. The birth of stars feeds the birth of worlds. The death of stars enriches the cosmic soil. Galaxies grow, merge, and transform, always shifting, always renewing. It is a cosmic dance, a pattern so vast and enduring that it stretches across billions of years. Yet, even in its immensity, it follows the same gentle truth we see in every star, that endings lead to beginnings, and that nothing in the universe is ever truly lost. The cycle of stars is not only written in the heavens, it is also reflected in the rhythm of our own lives. We, too, are born, we grow, we change, and one day we return what we have borrowed. Just like the stars, nothing within us is truly lost. The atoms of our bodies, the breath in our lungs, the warmth in our skin, all will one day drift back into the great cycle to become part of something new. This can be a comforting thought, that we are not separate, not fleeting shadows, but participants in a vast and gentle continuity. When you inhale, you take an air shaped by stars that live long before you. When you drink water, you are drinking molecules that have traveled through oceans, through clouds, through time itself. And when you look at the night sky, you are not just looking out, you're looking back into the past, into the story of how you came to be. The cycle continues within you each day, with every heartbeat, with every gentle moment of rest. You are carrying forward a thread in this endless cosmic story. And just as stars give light, you, too, leave traces of kindness, of warmth, of connection, that ripple quietly through the world around you. And so, as this journey comes to a close, let us rest in the comfort of knowing that the universe does not truly end things. It transforms them. It renews them. It carries them forward in ever-flowing circles. The stars remind us that goodbyes are never final, that endings are beginnings in disguise, and that within the silence of the night sky, we are all part of something timeless, beautiful, and eternal. And now, softly, I wish you peace. I wish you rest. And may the stars watch over you as you drift into dreams. Good night and goodbye.